Hello dear students, welcome to the TEQIP Faculty initiative of Let's Crack the Gate. Welcome to the classes of Power Electronics of Module 2. So, in this module, we are starting with AC to DC rectifiers. So, now if we come to the AC-DC rectifiers in power electronics, this is one of the major topic that is covered under GATE, and it also contributes to the maximum portion in power electronics. So, when we talk about AC-DC rectifiers, they are categorized under two categories. These rectifiers are also known as converters. Specifically, if I tell you, a converter means which converts anything from one quantity to another quantity, whether they may be DC to AC, they may be DC to DC, they may be AC to AC, or they may be AC to DC. All are termed as converters. So, here we are talking about AC-DC converters, or we are talking about AC-DC rectifiers. So, in this syllabus we have got two types of rectifiers. First one is uncontrolled rectifiers, and second one or second category is controlled rectifiers. When we talk about controlled rectifiers, there is further two categories, that is fully controlled and another one is semi controlled or half controlled. Please do not confuse it with half wave. Half wave is different and half controlled is different. We will talk in subsequent lecture series that what are these. So, when we talk about the uncontrolled rectifiers, these are those rectifiers which are constructed using uncontrolled devices such as diodes. That is why they are called uncontrolled rectifiers. But when we are talking about the controlled rectifiers, they are constructed using devices which can be controlled, such as SCR, thyristor, or they can also contain diode also. So, when we talk about this section of controlled rectifiers, we will discuss in detail what are these. So, let us have some quick recap which is also a prerequisite for understanding this section of the power electronics. First of all, we have already studied that there are three types of devices. We are only talking about two types. First one, uncontrolled devices. These are those devices whose turn on and turn off both cannot be controlled. Turn on as well as turn off both cannot be controlled. But when we talk about semi controlled devices, these devices are those which can be controlled. Turn on means their turn on can be controlled, but their turn off cannot be controlled. So, you already have studied about them. The examples like diode and diac, and here the best example is SCR, which is commonly known as thyristor. Actually, thyristor is the name of family. So, now some other prerequisites which are required to understand this section of power electronics is some basic electrical engineering concepts, also some mathematical concepts. So, first concept which you must know is that how to find average value of a function. This is very much required. So, if we have some function f t, and if you want to calculate its average value f average, then you know that average value is given as 1 upon time period integration over one time period function of t dt. This limit can be a function of time, or this limit can also be a function of angle or omega t, like this. This can also be written like that. If function is proportional to omega t, then this can be represented as like this, f omega t d omega t. So, now you please mind one thing, that I have written here integration over one time period. In some books you might written have, you have seen that they write like this, 0 to t. So, I have purposefully not written this thing 0 to t. It's because it's not necessary that you have to always each and every time you have to take the limits from 0 to t. Let us take some example which will make the concept very clear. For example, this is one of the wave with us. Like this. So, if you mark the time instants and so on. So, now if you see the time period here is 2t, sorry, time period is t. How we find the time period? We know that we start with some point and we have to see that means from where we are getting the repetition of the wave, alright. So, we start from anywhere. Now, we know that if we are taking two cases, first case that you are starting from 0 to t. Now, in this case when you start from 0 to t, you will see that if you break the function, because this is a discontinuous function. So, if you break the function, you have to break the function 3 times. First, you have to break 0 to t by 4. Second, you have to break the function, let us say it is t by 4. First function you have to break from 0 to t by 4. Then you have to break from t by 4 to 3t by 4, like this. And then you again have to break from 3t by 4 to t. So, if you see that if you take the time period from 0, if you take the instants from 0 to t, then you have to break the function 3 times. But instead of that, if you take the function time period from t by 4 to 5t by 4, like this. This is also the time period is t, capital T, but here you have to break the function only 2 times, from t by 4 to 3t by 4 and from 3t by 4 to 5t by 4. So, that is why I have written this integration over one time period, because we choose such a time period so that we have to break the function less to less in order to reduce our calculation burden. So, means with respect to this advantage, I have written this integration over one time period, and also I have shown you this generalized pattern or generalized equation, because when we are going to study about the 3-phase circuits, then there this integration over 0 to t might not work. That is why. So, it is not a hard and fast rule that you have to take always 0 to t. You can take any time period which requires less to less calculations or less to less breaking of the function. So, now moving on to the next prerequisite which is required to understand is that RMS value of the function. These are required in order to fully analyze AC DC rectifier circuit. So, when you talk about the RMS value, if you have got some function ft, then if you have to convert it into FRMS, then you can write like this: FRMS is equals to 1 over time period integration over one time period ft square dt under root. Or in terms of, if you want to take the limits as limits of omega t instead of t, then you can write like this also: 1 upon t integration over one time period f square omega t d omega t. You have already studied this subject about these things in basic electrical course. This means how we are putting the limits. If you are taking t, then you have to put the limits of time which is in seconds, and if you are taking omega t, then you have to put the limits of omega t which is in radians. Then the next very important prerequisite is Fourier series expansion. It is also required for the analysis of the wave. If you see, this is very important tool, this is very important prerequisite for the wave analysis, and if you see the last 10-year or 15-year GATE question paper, most of the section from the AC/DC rectifier comprises of this section, this Fourier series expansion, because it means many times it is required to analyze a AC/DC rectifier in terms of harmonics, such as their input source current, how much harmonic they are containing, and so means many other things. So, if you talk about Fourier series expansion of some wave ft, then this you know that ft, this Fourier series expansion says that any continuous time any periodic function can be break into its equivalent sine and cosine terms as well as DC term. So, this Fourier series expansion of some function ft can be written as a naught plus summation n equals to 1 to infinity, because we are taking single sided Fourier series, and a n cos n omega t plus b n sin n omega t, where a naught, a n and b n are Fourier series coefficients, where a naught is 1 over time period integration over 1 time period f t sin n omega t d omega t. If you want to take f omega t, you can also consider that. Similarly, if you see this a naught, it is nothing but is the average value or the DC value. It indicates how much DC component or DC bias, this is also known as DC bias. Please learn these technical terms, because in many of the competitive exams, whether it is GATE or any PSU exam or whatever, many times they use means very other terms also, means how we know them. Then a n is basically 2 upon t integration over 1 time period f t cos n omega t d omega t, and b n is again it is 2 over t integration over 1 time period f t sin n omega t d omega t. So, it is the advice that you please practice all these three prerequisites. Apart from that, another prerequisite which is required from basic electrical courses is transients, transient analysis of RL, RC and RLC. So, RL, RC and RLC circuits in terms of both mathematical and in terms of waveform analysis also. So, obviously, if you are talking about the transient analysis of RL, RC and RLC circuits, then you must know what is the behavior of an inductor and what is the behavior of a capacitor under switching conditions. We know that if we are having an inductor, it does not allow instantaneous change of current, instantaneous current change not allowed. Similarly, if you talk about the capacitor does not allow instantaneous voltage change. So, these properties of inductor and capacitor are also be taken into consideration or have to be kept in mind while analyzing or while drawing the waveform of power electronic circuits. So, this was about the prerequisites required in the study of this subject. So, now let us start with power electronics, and I am starting with the today's topic, that is uncontrolled rectifiers. So, when we go about the rectifier circuits, whether they are controlled one or the uncontrolled one, we have single phase rectifier circuits. If we are talking about what we have to study, whether they are uncontrolled one or controlled one, we have to study single phase circuits and we have to study 3 phase circuits. And in this single phase, again there is category. First one is half wave, we have to study, then we have to study full wave, and here also we have to study half wave, 3 phase half wave converters, and we have to study full wave. So, now today's topic, let us start with single phase half wave uncontrolled rectifiers. Please see this lecture very seriously, take this lecture very seriously, because in this lecture only I am going to discuss about the very basic step by step method that how we analyze the power electronic circuits, and means if I give you any power electronic circuits, how we analyze them. If you please watch it carefully, means I am going to tell many steps about this of this. So, single phase half wave uncontrolled rectifier. Now, see, when we are talking about single phase half wave uncontrolled rectifier, we know that we have got this. This is our load, this is diode, and these are my references, and whatever values I am showing here, all values are instantaneous values, they are not average values or RMS values. You know that in basic electrical course you have studied that whatever the symbols we represent in AC circuits, small letters if we are representing, they are all instantaneous values. So, this is diode, VD diode voltage, this is current reference, voltage reference, this is also current reference, voltage reference, and this is also current reference, voltage reference of diode. One thing you have to note, means make very clear that before beginning of the analysis of any power electronic circuit, you have to first of all define the references. The importance of reference is that if you don't define the reference, then you cannot say whether a voltage or current is positive or whether a voltage or current is negative. Just take very simple example, that suppose this is a wire, you can, and let us say this point A, this is point B. Suppose one current can flow, current can be bidirectional in this wire. The current can flow from A to B, let us say IAB, or the current can flow from B to A, IBA. So, if I ask you what current is positive and what current is negative, you cannot tell me. Suppose if you say that okay sir, let me take IAB as positive, then other one will argue that no, I will take IBA as positive. So, that will be a never ending argument. So, that is why we have to set one reference, that this is the reference, those who are following this reference are positive and those who are not following that reference, they are negative. Alright. Just for example, if no law is there, alright, then every outlaw will say that I am right. Alright. So, you have to set some reference point, okay, this is the law, alright. So, those who are following the law, they are called good citizens, and those who do not follow the law, they are called outlaws. So, that same concept here also, that if we have to first of all set some reference point, if you do not set the reference point, then we will face difficulty in determining whether it is a positive or negative. So, first of all define the reference point, and then those voltage and currents who are following the reference point, they are positive one, and those who are not following the reference point, they are negative one. And another thing, when we are defining the output voltage or load voltage, that is terminal to terminal, A to B. Why I am saying so? Because we are going to deal with a variety of loads when we are going to study about the AC/DC rectifiers. The load can be, let me chalk it out here, the load can be R load, the load can be RL load, the load can be RLE load, and the load can be RE load, the load can be RC parallel load, it can be L load, purely inductive load, it can be purely capacitive load, or it can be a RL or RLE load with freewheeling diode. So, we will discuss all these loads one by one. All right. So, let us start with our very simple circuit, that is half wave rectifier, uncontrolled rectifier with R load. So, here I am having this rectifier circuit. This is my source current reference and source current source voltage reference. This is my load voltage reference and load current reference. This is my diode voltage reference and diode current reference. All right. So, let us start the waveforms. Just a minute. This is omega t axis. Now, you see that in a single power electronic circuit, we have to make very means we have to make means very many waveforms. Let's just like in this simple circuit, we have to draw source voltage, we have to draw load voltage, we have to draw load current, we have to draw diode voltage, we have to draw diode current, and we have to draw source current. So, in this simple circuit, we have got 6 quantities to draw for analysis of the circuit. So, it is not possible, it is impossible to cram all the waveforms. So, just focus how I am doing, what steps I am telling you to draw the waveforms and then analyze it. Alright. So, first of all, first step is that first of all let me make the source voltage first, sorry. For example, this is my source voltage. Try to make the sine wave as accurate as possible, because if you make the sine wave as accurate as possible, then it will help you a lot. Alright, and let us say this is the amplitude Vm. Okay. Now, what we have to draw further is load voltage, we have to draw load current, we have to draw diode voltage. In our case, if you see in this circuit, load current is equal to source current and equal to diode current. Alright. So, now let us start with the first step of the waveform analysis or analysis of a power electronic circuit to draw its waveform. So, first step is that first of all you have to identify, first of all we have to understand that we have to analyze power electronic circuit instant wise. We do not take the circuit as a means for the whole time period. No, we have to analyze any power electronic circuit instant wise. Means let us say if we are getting 0, pi, 2 pi, 3 pi, 4 pi, 5 pi and so on, then you have first of all we will consider the period of 0 to pi, then we consider pi to 2 pi. And suppose if we are come to the controlled circuits, then obviously we will having some another, let us say I am showing here only, let us say we have got some firing angle alpha, then we have another instant in between, then first of all we have to analyze between 0 to alpha, and after that we have to analyze alpha to pi, then another gate pulse is there, then from that to that. Alright. So, first thing which you have to learn is that we have to analyze power electronic circuits instant wise. Oh, sorry. Alright. So, this is the first step. So, here if we see, if we are analyzing the instant wise circuit instant wise, we have first instant from 0 to pi. Alright. Then second step is that you have to see that during that instant what device we are using or what circuit device is there acting. So, we have to see the device status or what kind of device, we have to see kind of device we are using. So, here we are using diode which is an uncontrolled device. So, obviously, we have to know the property also of the diode. We know that yes, one thing I have skipped here and I remember not right now that what is this, that I am taking some assumptions while analyzing this circuit. First assumption is that all the devices have forward resistance as 0, means the devices are ideal. Second, the devices have forward voltage drops also as 0. Third, the devices have leakage current also as 0, because devices are ideal. And fourth one, that devices in reverse condition they are able to block infinite amount of voltage. Alright. So, these are the assumptions we are taking while studying these circuits. So, second is that what kind of device we are using, that is diode, and now you have to know the property of the diode, that we know that a diode is a device which when gets forward biased gets immediately turned on, and which gets when reverse biased gets immediately turned off. The diodes do not wait, they do not wait for any gate signal or something, because they do not have to. Alright. So, we have to see that what kind of device we are using, and hence we should know what is the property of the ideal characteristics of that device. Then, so here we are having a diode. So, we know that between 0 to pi the circuit condition is that diode becomes forward bias. So, now the third step is that after identifying what device we are using, then we have to identify that what is the status of device, what is the status of device. It means status of device means whether it is forward biased in that instant, or whether device is reverse biased in that instant, or whether the device is in forward blocking mode or what about conduction mode, whatever is there. So, that status you have to see, and after knowing that status of the device, what you have to do, you have to redraw a what to say that term, that you have to redraw a means a changed circuit, or you can say modified circuit. You have to redraw a modified circuit, because in power electronics we have studied that the major difference is that we use devices in switching state. We use devices as switches, not as amplifiers. Alright. So, you have to redraw a modified circuit. So, we redraw a modified circuit means we know that when the diode is forward biased, it becomes a short circuit switch, and when the diode is reverse biased, it becomes an open circuit. Alright. So, we have to redraw that modified circuit. Then fifth one is that after redrawing that modified circuit, you have to analyze the circuit by writing KCL and KVL equations. When you write that KCL and KVL equations for analyzing that circuit, then it becomes easier that what kind of output voltage or what kind of current is flowing in the device or in the circuit. Then sixth one is that before drawing the waveform or before drawing the load voltage or anything, you have to see what kind of load is being given, what kind of load has been provided, because without understanding the condition of the load, if you just jump over to analyze the circuit, you will end up in doing mistake. Alright, because earlier also I have just told you that when the load comprise of other than resistive element, that is inductive element or capacitive element. So, we know that these elements are storage elements. They do not allow instantaneous current or voltage change. So, that is why when we are dealing with the inductive loads or capacitive loads, in that case the current determines, the load current determines what kind of output voltage it should be like. Alright. So, that's why it is very important to know what kind of load is being provided, and after knowing that what kind of load is being provided, then we have to draw the waveform. So, these are the 7 steps which if we remember, and if in the starting when we are at the learning stage of power electronics, if we follow these steps for drawing the waveforms, then it will help you a lot in analyzing no matter what kind of complex circuit is being given to you. Alright. So, let us start with these 7 steps and start analyzing this circuit. Although this is very simple circuit, but believe me, trust me that this is a very simple strategy to learn the power electronics. These are very simple 7 steps to learn the power electronics. This is my experience of over 6 years of teaching GATE classes. So, let us start with this. So, first of all we have to take instant wise. So, we have here first instant with us is that we are taking the device from 0 to pi. This is my first instant. Then second step says that you have to see what kind of device is there. So, here we are seeing that the device is diode, means if it gets forward biased, it will get immediately turned on, and if it gets reverse biased, it will get immediately turned off. Alright. Then come to the third step. What is the status of device during this instant? So, between 0 to pi, what is the status of device? That you will see here that during 0 to pi, the diode is forward biased. So, when the diode is forward biased, obviously the diode will turn on. So, let us redraw a modified circuit, which is the fourth step. This is the modified circuit. I have replaced the diode with a short circuit, and like this. This is my V naught. Oh, this is V naught R. This is my reference load voltage, load current. This is source voltage. Here the diode current is going, and here the diode voltage is there. Now, when you draw the circuit, many of the things become immediately clear to you. What is the circuit condition? So, now the fifth step, that apply KCL KVL by seeing the circuit conditions. So, here you can see that the load voltage, if you mark this as AB terminal and if you mark this as CD terminal, then you can see very easily that the load is in parallel with the source. So, when the load is in parallel with the source, then you can say that V naught is equals to Vs. It means, and I have already told you that all these quantities are representing instantaneous values. alright. So, when they are representing instantaneous value and when the load is parallel with the source, obviously the load will follow the instantaneous value of the source. So, from whatever point the circuit becomes forward biased or circuit becomes active or load becomes connected in parallel with the source, so whatever value of the source is there at that particular instant, that the load will start following. So, here we are seeing that the load is source is already starting from 0 when the diode becomes forward biased, alright. So, obviously it will start like this and it will follow the source till the circuit remains active or the till the means diode remains short circuit. So, and the same Vm is here also. So, now when you talk about the load, so now we are writing, now you can also write the KVL KCL equation also here. From that also you can get this. How? Just write it. If you write the KVL equation here, you will get Vs minus Vd minus V naught equal to 0. Since it is a short circuit, so Vd is 0. So, that is why Vs minus V naught is equal to 0. This implies that Vs is equals to V naught. From mathematical also we can prove it, alright. So, we have got that. Now, load is also there. Now, we have to see sixth step. What is that? That what kind of load is provided? So, we are seeing here that the load provided is resistive load, and we know that in case of resistance, resistance is not a storage element, it does not try to means modify the circuit, alright. So, means in case of resistance, voltage and current are in same phase. So, obviously the load current will be of same nature as that of source voltage as that of load voltage. So, if you draw the load current, it will also be a sinusoidal wave. The only thing that can change is the peak value, means it can either scale up or it may either scale down, and its value is Vm by R, peak value. But if you talk in terms of the sinusoidal nature, it will be V naught by R. V naught is where instantaneous value, and then we are drawing the waveforms from based on this. And now, if you want diode voltage, again for that, to provide the diode voltage, you have to again go back to the KVL and KCL, and here we have already seen that diode is short circuited. So, when the diode is short circuited, obviously the diode voltage will be 0. I hope it is very clear to you people. So, now next step. So, we have analyzed for one instant. So, again going for the next instant, that is pi to 2 pi. You might be thinking that for such a simple, why this much complicated analysis is required. No, it is not complicated analysis. It is just like a baby step to make you learn that how we analyze the circuits in power electronics. And when you are taking the baby steps, then obviously you have to start with a small step. So, that is why I am starting with the simple circuits, because if you learn with the simple circuits, then only you will be able to apply it in the complex circuits. So, now going for the 0 to 2 pi instant, when you pi to 2 pi, when you go to pi to 2 pi, now again next step kind of device is diode. Then what is the status of device? Again check between pi to 2 pi, what is the status of device? The device diode is becoming reverse biased. So, when the diode is reverse biased, so here we can write diode on, and here we can write when the diode is reverse biased means diode is off. And when the diode is off, then the next step, redraw the circuit, modified circuit, then it is like this. Vs I naught V naught R. Now, here you can see when the diode is off, the circuit is becoming like this, open circuit. So, in this case what you have observing that the circuit is not disconnected, there is no connection between the load and the source. So, when the no connection is between load and source, obviously load current will be 0, and when load current is 0, then obviously load voltage is also 0, because there is nothing, because R cannot store anything across it. Resistance cannot store anything across it. Alright. And now if you try to write KVL equations, it is diode voltage is here. So, when you write KVL equations, you will get Vs minus Vd minus V naught equal to 0. So, here we can write, if you want to write the diode voltage, what is the voltage across diode, then it can be written as Vd is equals to Vs minus V naught. So, now, but V naught is 0, we have seen this. So, that is why the diode voltage is Vs. Now, here you can see that since Vs is represented as instantaneous value, but when you represent the Vs between this, not pi 0 to 2 pi, but when you represent Vs between pi to 2 pi instant, you know that between pi to 2 pi Vs is minus Vm sin omega t. So, it means that the whole negative voltage is applied across diode, and diode is reverse biased, means whatever voltage is there, that whole voltage is appearing across the diode. So, now let's so we have written the KVL and KCL equation also. We have seen the load, means since the circuit is off, so there is no need to see what kind of load is there, nor draw the waveforms. So, here we have already seen that output voltage is 0, output current is also similarly 0, but what is the status of diode voltage is equal to Vs, but what kind of Vs value? Between pi to 2 pi. So, between pi to 2 pi, what is the value of Vs? It is negative. So, the whole negative voltage will appear across Vs, Vd. So, that is the peak magnitude. So, if I told you what is the PIV rating of the diode, that is PIV rating of the diode is Vm, alright. So, that this much amount of diode rating you need. Again, now moving to the next instant, please note one thing, that when you are going to analyze a power electronic circuit, please at least analyze for at least 2 cycles. Do not just leave it for 1 cycle, please analyze it up to 2 cycles, at least 2 cycles. So, now again going to another instant, that is 2 pi to 3 pi. So, when you go to 2 pi to 3 pi instant, what you are seeing? Again the voltage is positive, and when the voltage is positive, device is diode, status of device, diode is forward biased. So, when the device is forward, diode is forward biased, it means the circuit will be like this, which we have already drawn here, and the same analysis will be applicable also. So, when the same analysis is applicable, so we can freely draw like this. This is the load voltage, this is the load current, and that is the diode voltage. And again, when we are going for 3 pi to 4 pi, then again for this instant we are seeing that the device is diode, the status of device is reverse biased. So, when the status of device is reverse biased, means diode is off, this circuit is applicable. So, when this circuit is applicable, we know that further and so all this analysis is also applicable. So, here we can draw the similar waveforms here also. Output voltage is 0, output current is 0, and diode voltage is like this. So, in this way we analyze the power electronic circuits. So, this is quite a simple method, quite simple steps. If you remember this is well and good. Now, after this, the next step which comes is the mathematical analysis of the power electronic circuits. So, in mathematical analysis, what we do is that we analyze circuit in terms of average value, in terms of RMS value, in terms of Fourier series. So, now first of all we are going for the average and RMS value of this circuit. So, again if you see the circuit, the time period is 2 pi, alright. So, now it is a homework for you that you have to determine what is the V naught average of this circuit and what is the V naught RMS of this circuit. Please write it in comment section. You have to practice this. Okay. So, when you analyze this mathematically, then we will get these values also. So, now this is for the R load. So, now let us have some quick recap of the steps again. Then I am again repeating that these steps, that how you analyze the circuits, that first of all take the circuit instant wise, that at each instant you have to see what is the kind of device we are using, then what is the status of device between that instance, then redraw the modified circuit and then apply the circuit equations KVL, KCL, whatever is there, and then see what kind of load is provided. So, based on that load current, the load voltage will be accordingly, and then draw the waveforms and analyze the circuit mathematically. Alright. So, for this lecture, this much is there. In the next lecture, we will discuss about single phase half wave uncontrolled rectifier with various other types of loads. So, if you like the lecture, please like, comment and share the lecture with others also, so that others can also be benefited. And for any queries, please post your queries in the comment section. Till then, thank you very much.